Good morning. Welcome to the Track A product demo track for the day. You're going to hear from Mr. Tom Brennan of Artemis Vision, and he'll be explaining one of their products, Vision Wrangler. Correct? Yep. Well, I'll let him explain what it is. Thank you again for coming.
Great. Thank you, Josh. So just quickly about us, we were founded in 2010. We have a worldwide customer base, but primarily US and Canada. We build high-performance vision systems and software tools. And we have a complete in-house vision lab as well as a full machine shop for fabrication. We have offices in Denver, Dallas, and Charlotte. We're an Automated Imaging Association member, and we're actually an AIA certified vision system integrator. We offer turnkey end-to-end vision solutions, and most importantly, for this presentation, we offer networked corporate level visibility into quality. So we offer the ability to network your vision systems so that you can view them through a web browser, and you can monitor the quality at various different facilities. And like Jim was saying earlier, if you can measure it, it gets improved. So today's problem with vision systems. We have a lot of vision systems that verify, they inspect, they dimension, they track parts, they do all sorts of things. But then we have complaints that come back from the field or issues that come up, and we can't link those to the actual inspections. We have these reports of problems, but there's no solution tying that reported problem back to the actual part and the inspection data on that part from the vision system. So basically, it becomes then time-consuming to look into problems. And because it's time-consuming, and we spend a lot of time investigating problems that might not really be a problem, the real problems sometimes get ignored. And then they get lost in the shuffle, and then it becomes a crisis later. And then we have all the associated problems of chargebacks, right, rework, scrap, and the inability to run lean, right? If I can't know all that inspection data before the part's shipping and send it downstream to my customer, then they're going to have to deal with inspecting it inbound, and that's going to prevent us from running lean. So today's customer wants to simplify that process. They want to simplify the complex supply chain. They want a single vendor that they can collaborate with globally. And they want a consistent product worldwide, no matter what plant makes it. They want those deliveries to always be correct, to run their just-in-time lean operation. And they want data and visibility to make improvements. They want to be collaborative with their supplier base because a lot of today's manufacturing world is collaborating with your supplier base. So to serve that, today's supplier needs automated ways of gathering data to monitor their operation. And they need that at multiple plants. They need to be everywhere at once, even though they can't physically be everywhere at once. And they need that data to be repeatable across shifts, plants, production runs. So they need vision systems that are at each plant, and they need those networked together so that they can monitor their quality in multiple locations and tell their customer that, yeah, we track that, and here, if you log in here, you can see that data. They also need 100% inspection quality without adding significant costs. You know, if you're going to inspect 100% of the parts, doing that by hand adds significant cost per part. Doing it with vision, it's a one-time capital investment. And they need to score better on their quality scorecards. A lot of customers are now implementing quality scorecards and getting rid of suppliers that, you know, are the lowest performing. And that can be disastrous for the business to get eliminated. They also need tools to build trust and be collaborative. So the technology that we offer, called Vision Wrangler, basically tracks your vision system results. And it's a turnkey solution. It comes complete with all necessary hardware for plug-and-play operation. You can track product, track quality, and report that via the web interface. It's also built on top of open source software, so there's no issue. You don't have to worry about whether the solution is future-proofed. You can always go in and modify the open source database that underpins the software. And the critical thing that this offers is it's now easy to store and share production data with third parties. So instead of just telling people that we completed this inspection and here are our numbers in the spreadsheet, you can share images, you can share results, and you can do it automatically. You don't have to gather that data, put it on a thumb drive, take the thumb drive back to your laptop, then send an email. It just gets automatically shared. Now, this is a software platform. It works with any vision system brand of camera. We also build vision systems, so we can build the system, or you can have a data logic system or whoever's system that you want feeding into the software. So each part gets serialized, and then the inspection data gets stored with that serialized part with the actual images. Those records can be searched. You can get configurable alerts, text messages, emails, whatever you want. And then you can also have a record of those alerts. You can track whether quality is improving or not. You can get various reports out of the system. You can track those reports, try to improve operations, and biggest sometimes is you can keep production moving by knowing about problems immediately, even if you're not at that plant, right? If you're getting the quality data from the vision system, you know what's going on. So some customers that use this, we'll go through just 3 quick examples just to give you guys an idea of how this can get applied in your process. We have a US automaker, a Fortune 10 company that ships pharmaceuticals, and then a Dow component. So the automaker uses Vision Wrangler to track component inspections, specifically in the frame. So they track all the inspections, and then when there's assembly issues, right, similar to the example that Zach was sharing about Toyota, where an individual worker on the line can pull a cable and stop production due to a quality problem, right? This automaker can now look up images of actual inspections every time there's a quality problem immediately and get to the bottom of it. And this is helping them ramp up production. They're now able to, whenever something comes up, instead of having it be everybody shrugs their shoulders and we just keep making product even though we know there's a problem, they can take that part back, look up what the problem is, make an adjustment, get to the bottom of it quickly, and improve. And then they can also, if they're going to propose an improvement, they know from querying that image data what other parts that's going to impact. So on a complex part with 10, 20, 30 tolerances on different dimensions, right? If we change the tolerance on one dimension, right, that has impacts through the rest of the part, they can now query that data and figure that out. So the pharmaceutical customer, they use Vision Wrangler to track the drugs they ship and the labeling and patient information. That helps them address called-in patient complaints. So when I call in and say that you didn't ship me this, you didn't properly label this drug, I can now pull up images and say, no, we actually shipped you 3 vials as we were supposed to. Here it's all labeled properly, and here are the images. And then if there's further complaints, right, we can push back on FedEx and UPS or the carrier or somebody else who might have damaged the product and make them eat that charge instead of us eating the charge and shipping out new product at our expense. So this has greatly reduced the number of false complaints they get because now their customers know that, and also the shipper knows, that this customer has data. and they can prove that they did their job right. So the DAO component uses Vision Wrangler in a different way. They use it to license production to a third party. And then that system is hooked back to theirs so that they can make sure that that third party is producing the product to their standard. They basically have to put it through the vision system before they ship it, and then by monitoring that, this DAO component can verify that that third party is making things exactly to spec, the way they would like, and that the data going into that Excel spreadsheet isn't just somebody fat fingering whatever number needs to go into the Excel spreadsheet. It comes from an actual system that's much more tamper-proof. And this greatly reduces the risk to their brand and allows them to subcontract more confidently. They can basically deploy a vision system, tell the supplier that they need to use that vision system, and then keep tabs on it. So what this software product supports is basically a concept of we can now ship the data before we ship the part. And that really helps us clean up our global supply chain. It helps us reduce our transportation costs, reduce disruptions, and ultimately, we can make the vision systems toll booths that work for us. If we're the one that puts the vision system in, right, we can bill per contract based on a number of defects, based on whatever it might be, because we now have data on that. It's no longer an issue of the shipment goes out blind, it arrives, it's either accepted or rejected. If we have a vision system in place, we can enforce the contract before it leaves the supplier facility. We can basically say that if it meets this spec, we'll pay per the contract. If it does not meet this spec, it's a lower grade, and we will pay X rate. So just real quick, a product demo here. And this is actually from the pharmaceutical example. So you'll see here we have a search field, right? Somebody calls in to talk about an order, to basically say that something was amiss. We can go through, we can see all the vision system results, where exactly various inspections were done. We can scroll down and we can see each of those inspections. And then, if we type in another product, right, we can go through and we can see the inspections on that one as well. Basically, by doing this, right, we're able to diagnose a problem quickly and easily. And that's the core value of the product to our customer base, is that previously, if somebody calls in about a problem in production, you wouldn't be able to say much about it besides, I'll look into it, right? Now we can look into things immediately, and we can diagnose what's going wrong and make continuous improvements. Any questions about Vision Wrangler? Okay. Yeah.
I have one. Are there technical limitations as far as like image quality size or file size that are being captured or shared or anything like that?
So that's implementation dependent. Basically, depending on how many parts the customer does per hour, right? We then compute basically how many gigabytes they're going to need per hour to store that data. And some decision essentially gets made of, we're going to store a month, we're going to store 6 months, we're going to store a year's worth. It's largely just a matter of purchasing hard drive space.
And then a follow-up to that. Are you offering just a software solution, or do you also do a hardware side of it for an on-site, or is it cloud, or both, or how's that part of it work?
We've done it both ways. We've found that if you go into it like saying this is the only way it works. The IT department says, no, that's not the way it's going to work. And so, we've done it where it's hosted at the customer site. We've also done it cloud-based. It depends on what the customer wants. The more typical way is behind their firewall, because then they control the solution and there's fewer security concerns because it's basically their responsibility to maintain that firewall.
Thank you.
Okay, then hand it over here.
I don't think I need the microphone, but I'll stand over here if you want. So what we're going to do is this sort of a product presentation. We'll let Phil Lewis, a colleague of mine, represents our Icon division. We have the product out here in our booth if you want to stop by and take a look at that. And then Scott's going to maybe talk a little bit about the Roamer arms. But it is the largest portfolio of products in the world as far as measurement companies go. So that covers CMMs, laser trackers, vision machines, multi-sensor measuring machines. So if you got any questions about those other products, feel free to stop by and we can talk to you about that as well. So I'll let Phil go and he can talk to you about the Icon product.
All right. So I'm just going to grab the slide presenter here. I'm Phil Lewis from Hexagon. I'm part of the Optical team, 3D Optical Systems group. And what I'm going to overview today is just a part of the part of our product portfolio, which is our hardware-based optical scanners. So as Tom mentioned, we have a huge amount of technology, largest metrology company in the world. So this is just one piece of the pie here at Hexagon. Earlier today, you may have been in the keynote. You saw Zach speak about Hexagon. Hexagon overall, we want to build smart quality, smart divisions within our company, right? And part of Hexagon is what you see here is that we work with our customers to improve the productivity by embedding quality throughout the entire product life cycle. So that's very important from start to finish. And what I like to always think of and what we say here at Hexagon is we want to rethink quality. So it's very important to understand in your company and what your processes are and how to emphasize on those processes and expand upon them. And part of what we do, again, at Hexagon is is with our hardware and software, we fuse the real world and the digital world together. So from sensors to software, we could take information gathered throughout those two worlds and bring them closer together so that we have better process flow, better efficiencies, and quality products at the end of it. Oh, yeah. Sure, of course. This won't interfere with the mic. Okay. So again, part of my job here is at Hexagon is the 3D optical scanner solutions. And our 3D optical scanner portfolio is really large. We have the most comprehensive optical scanning portfolio on the market for any other customer or company that's out there. We split our portfolio up with optical scanning into part inspection, reverse engineering, and shop floor solutions, both of which are, utilize the optical scanning technologies somewhat differently than each other. But what that means is we could fit that optical technology into your process, depending on, again, what you're looking to do for the end result. So I want to focus a little bit on just the part inspection and reverse engineering aspect of it. And that's our optical portfolio line that you see on the left there. When we look at the optical line for part inspection and reverse engineering, we need the highest quality, the best data that we could acquire. So we use a technology called structured light that some of you may know as blue light scanning, fringe projection, et cetera. We use dual cameras. We use a projector with those cameras, and we can acquire really high detailed replication of the part that we're scanning, where the detail the geometry reconstruction is very detailed based on the points that we're collecting. So with the tools that we have with the optical scanning for reverse engineering and part inspection, you can really drive down into your processes and inspect those parts at a much higher level than just single point or lower end point production. So some examples that we have here with 3D scanning. One of our optical scanners is called the StereoScan Neo, and it's what we like to do with these optical scanners is pair our turntable solutions with the scanners. So you can see in this video, a part or a product is easily placed on a turntable. With just a few clicks, you're already scanning the object. So it's a very hands-off approach, very automated. At the same time, all of these type of, for this process, you're able to capture a lot of information very quickly. So instead of just running through the entire scan here, I sped the video up so we can see the end result. So at the end of the day, we have a full replica, digitized replica of our object. And now we can take that high resolution replica and look at it on a comparison to CAD or a known nominal value. Because of the high quality and the high resolution based on that STL, we can extract information from the actual digitized model very quickly and easily. So you can see some of the screenshots here of what that digitized object looks like. Again, hands-off approach, very fast data acquisition, and very high quality. And also another part of this is called, with this type of solution is, with our optical scanners, we have the ability of what we call back projection. And this back projection technique is the only available on the market from our high precision portable optical scanner, the StereoScan Neo. So back projection is what you see when you're, I'm sorry, the color map is what you see when you take a scan and you compare it to a CAD model. Usually you're looking at a PDF form, you're trying to understand where the part surface deviation is deviated from based on a color map, and then you go out to the part, to the tooling, to the tool, the object out on the floor, and you look at it, and then you kind of figure out where on that tool it was marked up or high or low. Well, with back projection, we have the actual capability of taking the scan data, doing the comparison, and projecting the color map or the deviation right back onto the physical part. So now you can see on the physical part, based on the color map, where your highs and lows are. And there's a couple examples at some of our customers where you see this happen, where you can take that information and see it right then and there on the actual floor, out on your production area, right by the machine, and you can make quick decisions and assess what's going on with your components fast. And that's, again, that was kind of the key with what we're talking about with Hexagon, is bringing processes, bringing different processes together and making quick decisions and smart decisions out on the manufacturing floor. Here's a couple other examples on that. So fusing the real and digital worlds together will give you quick, dynamic, and actionable information that you can make quick and fast decisions. So I have one more video here. This one is also showcasing one of our scanner solutions called the Prime Scan, optical scanners. In the small part industry, we have a lot of dimensional information we need to acquire. So again, by pairing the optical scanner with the turntable, we can really automate that type of process and inspection. So here's an example of small parts. It's simply just placing the part on the turntable, telling it how many rotations you may need, changing some parameter settings, and then scanning the object. What's nice about our solution is that you can save those type of parameter settings. So if you have multi-pieces, shop floor person number 2 can come in and just select the template. They don't have to understand how many rotations do I need, how do I set up my parameters. So now we're getting into more of a semi-automated solution that can be pushed through operators that are not metrologists, or not quality engineers. This is very helpful, again, to build that and drive that the process and assessment that you're looking at within your company. Here's another few examples, again, of the quality of data. So you can see that the small little detail there, that arm there shows 0.2 millimeters between on the arm's thickness there. So we can really get high detailed data from the optical scanning. Again, another small part. This one's a molded part, and it looks like something that we might not necessarily measure, but in this case, we can measure the entire object, and you can see here it's a 4 millimeter width between the walls. So the optical scanning world has come a long way to be able to acquire really good high detailed data from small parts to even large parts. And overall, these are some of our plethora of application areas where 3D optical scanning is now being introduced heavily into. And one thing I want to comment on too in 3D optical scanning world is that we find that a lot of our customers who are CMM and tactile based can drive about 60 to 70% of that work over to the optical technology and then leave the CMM open for more throughput and more job. So again, we're increasing the process and efficiency within the factory or within that company by them acquiring a new technology such as 3D optical scanning as well. So again, we're over in the atrium, but there's one more section that we want to talk about here. And Scott Smart, he's with our Hexagon Absolute Arm group. And I'll go to the next slide here because it's a video that we can showcase.
Thank you. This one? Okay. As Phil said, my name is Scott Smart. If you've heard of the Romer arm, you'll see it here on the screen. This is our new RA8 arm that just came out here in late August. We have our 3 different models, our 85, an 83, and an 87 series, or kind of a green, blue, and platinum titanium color series. So these are the new arm that came out. It's got some updated features from our old system, which would be the RA7 Absolute arm. You'll notice we've kind of revamped the style of it and the way it looks. We've come up with our same technology, I guess, in the way of our control packs or feature packs. We have 2 batteries, can scan wirelessly, connect wirelessly, all those features. We still have our wonderful zero G counterbalance, along with our dual tubing carbon fiber for all of our linkages to give a nice, strong, sturdy product. Along with a new couple little feature when it locks into place and kind of protects it. Moving up, when you get down to the RS5, hopefully this loop again. When we get down to the end to the RS5, we have now made it removable and repeatable. So as you're scanning and you're going through things, if you needed to, let's say take the scanner off to get down in a bore or somewhere in a piece of flooring or something, to really get in there, you have the handle and the probe to do that. If you want to flip that around and take the handle off and just use the scanner and the probe, you have the ability to do that. If you want to take the scanner and the handle off and just use the probe, you have the ability to do that. And that was kind of the basis of moving into the RA8 and making it versatile in every aspect that you need. Right? You can change and take things off, put things on to make it exactly what you need for any situation within the product. Then we still have the great technology with the hard probes, so you can take them, they're hot swappable, and they don't need to be recalibrated or calibrated when they get there. Everything comes from the factory, shows up, and it's all set to go. The tips are replaceable as well on the probes, and if you'll notice, there's a little screen here that'll kind of go through. the screen shows the different like RDS functions. You don't always have to go back to your computer. You can kind of switch and maneuver things right on the screen. In the future, they're going to bring that in, incorporate that into the software that you're using, so you can kind of really quickly look at the features and how many holes or how many points you've taken on a feature. It'll be on that little screen. So it's just kind of some new technology that's on the way. And that's it. Thank you very much.
Any questions for any of these three gentlemen?
If you guys do have any questions, you can come out to the front area and stop in and see us.